Lesson 7.8 is on the recursive formulas. I apologize, but my tablet is not working in this video, so I'm just going to use the book's version with it all typed in. So anyway, in this lesson, you are going to learn to use recursive formula to list terms in a sequence, as well as write recursive formulas for arithmetic and geometric sequences. So for example 1, it says, find the first five terms of a sequence in which a1 equals -8, an equals -2 times a of n minus 1 plus 5 if n is greater than 2. So basically what a recursive formula does is it builds the next term based off of the previous term. So in this case here, this -2 times a to the n minus 1 is saying 2, to figure out the term an, you're going to multiply it by the term right before a of n. And then you're going to multiply by -2 and add 5. So if I want to find a2, I'm doing a2 minus 1, which is going to be a1, and that gives a1 was -8. So I put in -8, so -2 times -8 plus 5 is equal to 21. So if I want to find a3, I'm putting in 3 for n, and then that's going to be, when I do 3 minus 1, I get a2. So to figure out a3, I need to know what a2 was. And a2 was 21. So I put in that 21. So I have 21 times -2, and then I add 5, where I get -37. And continuing that pattern, you're going to get a, 4, and 5. So if you look at those for a quick minute and see if you understand it, copy them down. Plugging in 4, you're going to need a3. To find a5, you're going to need a4. And the pattern continues. So at the end, after you have all of them, you should have -8, 21, -37, 79, and -153 as the first 5 terms of this sequence. You guys try this one. Okay, if we want to be able to write a recursive formula, we're going to use the formula for an arithmetic sequence as well as a geometric sequence. So remember, we already learned for an arithmetic sequence, that's when you're adding the constant each term. So if you know what term before it is, you just add what the difference between each terms is to get back to the new form. And if it's geometric, that's when you multiply each previous term by the next one to get it. So you would just multiply it by r, where r is the common ratio and d is the common difference. So add d, multiply r, times the previous term. So if I want to write a recursive formula for the sequence 23, 29, 35, and 41, the first thing we want to know is if this is geometric or arithmetic. So are we multiplying by a constant each time, or are we adding? In this, each term subtracted from the term that follows it, we're going to get 6. So there's a common difference of 6. Therefore, the sequence is arithmetic. So we're going to use our formula for an arithmetic sequence, which was a of n equals a of n minus 1 plus d. And so we're just putting in 6. And then that's our formula. So then we just want to specify and say that a of 1 is 23, and n has to be greater than or equal to 2. Okay, if we want to write a recursive formula for this sequence, this one, it's obviously going to be multiplication rather than addition or subtraction because it's switching from positive to negative, and you can't do that by adding the same constant each time. So we want to know what that constant is, and it's -3. So we figure out there's no common difference, and then we see that there is a common ratio of -3. So we know this is a geometric sequence. So we're using our geometric sequence formula. And I put in -3 for r, and that basically gives my sequence. I just want to specify that a of 1 is 7, and we're saying n is greater than or equal to 2. Because we don't want to be putting in the negative, because we're moving forward in our sequence. We're not going backwards. We can't have less than our first sequence. Okay, you guys try this one. Oops, okay. So example 3, the price of a car depreciates at the end of each year. Write a recursive formula for the sequence. So for this one, again, we want to see if it has a constant ratio or if you're adding the same number each time. And in this case, it has a constant ratio when we do it of 3/5. If I take each of the numbers and divide by the number before it, I get 3/5. So there's a common ratio of 3/5. The sequence is therefore geometric. So I'm going to use my geometric formula, which is a of n equals r times a of n minus 1. I put in my r, and then I just want to specify that a of 1 is 12,000, and we say that n has to be greater than or equal to 2. Okay, and this is something. Okay, you guys can try this one. And you should get B. Okay, the last thing is we want to be able to do is to translate between recursive and explicit formulas. So this currently is an explicit formula. And we want to write a recursive formula. So this is what we learned before. So this is like for any n that you want to find out. So if you want to find out the fifth term, you put in 5 for n and you can do it. But if we want to switch this to recursive formula, we need to figure out what our difference is. So let's figure out for you the first term. So if I put in 1, I'm going to get 2 times 1 minus 4, or negative 2. So a of 1 is negative 2. A of n is therefore going to be a of n equals n minus 1. A of n minus 1 plus 2. Basically, if I were to keep doing this, I would get the terms negative 2, and then I would get 0, and then I would get 2, and then 4, and 6, just plugging in 1, 2, 3, 4 for n. So therefore, the difference that it's changing by is 2. So I'm just putting in the 2 here into my recursive formula. Okay, if I want to write an explicit formula for a of n equals 84 and a of n equals 1.5 an. So if you remember from a previous section that our formula anyways, so we need to use a of n, and then it was the rate to the power of n minus 1. So our a of 1 is here. Our rate is 1.5. So this number in front here, if this was in recursive formula, that's the r. So our r is going to be the same as in our explicit formula that we learned in the previous section. And then it's n minus 1. And that gives us a of n. And that's the answer. You guys try this one. And you're done. Hopefully this worked okay. Sorry about the pen. Hopefully I'll figure out why it's not working by tomorrow.